welcome back to the shop. Let's take a quick look at this power drawbar. Well, here it is. This is the power drawbar as is, and in this video we'll take a look at how we built this. So sit back and enjoy. There we go. So this is the hydraulic cylinder. This cavity here is filled with oil, or will be when I've made it. It's a chunky piece of steel. This is 3 inches, 76 millimeters, and it's EN1A. EN1A, and it needs to be 70 diameter by 70 long. So I'm going to cut it so I've got a little bit of spare. Actually, we'll go just shy of 80. Right, this is going to take the length of a good cup of tea. The first stop is to face the bottom of this cylinder off and then turn it to 70 diameter and then bore it out for the piston, for the power piston. I've opened up the power cylinder bore, and after 5 minutes polishing, we've got a pretty acceptable finish on that. Right then, that's all the operations I can do in this end for the power cylinder. So let's take this out, flip it round and put it in the 4-jaw and get it running as true as we can. I think I'll buy that. I've got to turn this, which is, I think, 76 millimeters or 3 inches, down to 30 mil diameter, which is about 1.25 inches ish. I use this. It's a trinome insert, WNMG. I don't know. Anyway, I'll put it up on the screen what it is, but this is a damn good tool for roughing. It will rip this stuff off like it's butter. So let me get that turned down and I'll call you back when I've finished it. After 40 minutes of turning, truly terrifying turning, after a bit of a clear up, we're nearly down to the right diameter. So I'll just finish these dimensions off, and then we need to thread this with an Acme thread. I've cut a little chamfer on the end and a run-out gutter for the thread. We're going to fit, or we're going to cut, this 12 TPI Acme thread. The included angle is 29 degrees, so I've put the compound over at half that angle, 14.5 degrees, and this is how I did it. 14.5 degrees. This is the angle between these two, and then sight this edge along the cross slide edge. It's a bit tricky, but with a little bit of jiggery and pokery, you can, and a decent bit of light, you can get it reasonably accurately. I've put the tool in, and that lines up perfectly with the turned flange. Over the back here is a little gauge that measures the in feed of the cross slide. And here is my little LCD dial test gauge that's measuring the in feed of the top slide, or will be. There we go. So I have I know that I've got my tool in the right position for each pass. That's about as close as you want to get. Here we go. I'll just measure that. So starting at 1 inch, so we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That looks like 12 TPI to me. I shall do this, cut these threads and get back to you when I've finished. Half an hour later, we have a finished and polished Acme 12 TPI 30mm diameter. That's a bit of a bastard, isn't it? Thread. So next up is to bore out the end all the way through to the major power cylinder at this end with the drive cylinder, which is 12mm. So I need to drill that out, bore it and ream it. Also, it's nice and concentric. It has to be concentric with this threaded portion, otherwise the nut that's going to go on there to drive the piston up and down will jam. Here's a quick shot of the setup for machining the O-ring grooves. As you can see, I've ground up a little tool that matches the cross-section of the O-rings I'm going to use, and I just need to plunge it in and cut 2 grooves inside this bore. So I'll do that off camera because it's you can't see anything anyway. I can't see anything, so it's just the way it is. After what seems like an age, there are 2 O-rings in there, 12mm. There's a 12mm diameter hole with a really poor surface finish and 2 O-rings to seal it. I now need to put some holes in this boss here, which I will do on the mill. Here's the setup. The hydraulic cylinder force multiplier is in the rotary table chuck. I've got a point in it just to as a sanity check to make sure I'm still over the top of the centre. I need to move over 23mm in the X and then start punching holes in. Got a bit of stainless steel in here, which I'm going to make the power piston out of. I've turned it to the snug fit diameter in its cylinder, and now I'm going to just groove it for the O-rings. I want to go 1.5 in, 1.5, and just touch off. 0, that. Now I want to feed in. These O-rings are 3mm thick, so I want to go in about 2.8. have to slow the lathe down. That's clearly too quick. Soluble oil, I should say. Oh, that's better. Here we go. Here's a test fit. Perfect. There we go. Drop of liquid splodge. Well, hey, you should see the bottom piston's pushed out. Okie dokie, I've whipped up a phosphor bronze blank which is going to be tapped to suit this Acme thread. That's 30mm diameter by 12 TPI. Yeah, I know. What can I say? This dimension is supposed to be 27.88, so I'll call that a win. I'll cut the rest of this off camera because it's just a rinse and repeat for this operation. Here we go. After messing around for over an hour, I've got a thread that works. There's a tight spot in the middle. No idea why. You know you're working the machine hard when the chips come off blue. That's the power nut that's going to go on here. It's I've bored it out for the 12mm piston, so as this goes up and down it drives the piston in and out, and it's counterbored for a friction fit on this phosphor bronze nut that I made the other day, yesterday, and so the next thing to do is to take this and cut this anvil shape on the top of it, this anvil fits this drill like so. So next up is to do that. So over to the jolly old mill. After a few minutes with the file and a wire wheel, I've cleaned it up. This was the original anvil. That's the hammer. That's the anvil from the original cheap drill. So, don't want that bit. I want this bit. So this is my my copy. Quite chuffed with that. That seems to be a pretty good match. And more to the point, that fits. I don't think I'm going to harden this. I'm going to just see how we get on with where it will fall to pieces, I'm sure. Next up is to this is counterboard to accept the phosphor bronze nut, which is in the freezer at the moment. It has been for the last hour. So I'm going to heat this up and drop that in. I've made one support ring for my motor for my power drawbar. So this is I need two. So this is the next one. I've decked it off to 12 heads. Oh, that rings well. To 12 millimeters, and there we go, 12.01. If you can see that, that's for me, that's bloody close. So I'll just change the tool from my fly cutter and put in a 5mm full flute end mill, and we'll hog the centre out. Looking forward to the day when I don't have to do this anymore. Whoops, damn it. That's one of the reasons it's too easy to drop the tool out and break it. Luckily, no damage either way. Hurrah! We've cut all the slots. Now I need to just change the tool and cut the outside profile. So we'll get on with that. It's been another week of work, and I'm back in the workshop to do some more on this power drawbar. This is where I got to. I'd cut out the support rings for the motor. Now they need to be bored out to fit on here and on this step here, and to do that, because these things are sprung effectively, they're going to clamp. I need to put grub screws in that are going to apply the force to lock these in place. So I need to put grub screws in through here, and once I've done that, then the grub screws will hold this flexure in place whilst I machine out the internal bore. So that's the next task for those. Put those 6 grub screws in. Also, being a complete numpty, this is the shaft I'm going to use. Can you see that? Just about. Yeah, this is the shaft I'm going to use for instead of these this M8 threaded rod. I've got another video that I made to show you where these came from, but they're out of printer cartridges. They're quite nicely made, and for some obscure reason they should be a nice slidey fit in there, but that's as loose as hell. So I'm going to have to turn up some bushes. I think what happened was I either got the dimension wrong in CAD, which is possible, or I got the wrong size of cutter in the mill when I made the part. Either way, it's too bloody loose. So I need to turn up some what do you call them? Bearing flange bearing things to go in there. Zeroed all the axes with the with 2 points in one in the spindle and obviously one in the rotary table, or 4th axis as we should call it here. So now it's a case of putting this on and getting the x-axis sorted out, and then we can start drilling holes. Here's a shot looking down the axis of the 4th axis, and you can see that the jaws of the 3-jaw chuck are on the solid portions of this ring, not on the flexures. If they were on the flexures, there's always a possibility that the machining loads will knock it out of the chuck. So let's get on with it. I've moved the cutter 6mm that way, so that it's in the middle of the thickness of this this clamp ring, and I've just eyeballed the axis for the grub screw to go in here. So it's absolutely not critical. So that looks to me close enough. I'm doing this manually. Here we are. I have drilled and tapped 2 grub screws in here to trap the piston. Goes in there, and I've also I've drilled and tapped the holes for the grub screws that impinge on these flexures, so now I can machine those out. But first I'm going to make this piston. This is the diameter 12 silver steel. I've measured the length of this. I've also measured just how deep the two O-rings are in there. So if I add 10mm to the length of this, and that is 70mm, near as damn it. So if I cut this off at 80mm, then the piston will hang out of the end by 10mm. So when the thread falls off here and it stops driving that way, the piston will still be in the bore. I'm not entirely sure whether that's going to be good enough, but we'll see. I need to try it, put it together, get it all finished, put it on the mill, and then I can adjust lengths, etc. as required. This is going to be tricky though, because I think I'm going to harden it. Anyway, having cut it off to the right length, I then need to drill a hole all the way through it, and that's so that you can get the oil in, fill this up with oil, push the piston in, the oil will squirt out the top of the hole, then there'll be a tapped grub screw in there to seal it up, and on top of that, where is it? Here we go. This is the anvil that goes on the very top, and it's got a hardened spigot of 8mm. So I then need to counter bore this 8mm so that it keeps this anvil concentric. So if the piston's coming up the middle of the hole, then it's going to have to have an 8mm flush. It's got to fit flush with the top here, and then have an 8mm hole to accept that spigot. So that's a bit of a complicated part, but I'll go and make that, then come and explain it. I'll do it off camera because it's all simple turning work. So cut it off, drill a hole, counter bore it, drill another hole for the tap screw, tap it, job done. I thought I'd just include this shot. I'm using the E32 collet chuck that I made in an earlier video. I'll see if I can put a card up so you can, if you're interested, you can see how I made it. But this is the most accurate work holding I've got for this lathe. So I'm just finish this part off. I just need to face it off, drill it, and counter bore it. Here's the piston, and as you probably can't see, there's an hole all the way through. It's counter bored at this end. It's also got a double counter bore, and there's an M4 threaded hole in there, which means, there we go, that is how you set the oil level in it. So that screws in there and jams this hole up. I've filed a couple of flats on it, and it fits neatly in here. And these two grub screws do up to trap it. So that works okay. Here's the motor that's going to do the business. So this is counter bored at 8mm, so that it fits on the centre of this. Yeah, I'll turn around so you can see it a bit easier. The centre of this impact driver guts. So almost a decent fit. This is the cylinder arrangement, the hydraulic cylinder arrangement. There's the big cylinder. This is the small cylinder. What you do is you fit this piston in there, fill this full of oil, push this in till you can engage the threads on here, and oil will squirt out the top because you left the grub screw out. Once you've got it to that position, then you put the grub screw in, do it up, and you've got a sealed cylinder that's got the right amount of oil in it. That's the theory. I have tried it. It does seem to work. I'm not sure this is going to last more than a few minutes, but we will see. I'll give you a close-up. But the anvil on here, or the hammer, this is the anvil, is, well, fallen to pieces quite easily. There you go. You can see the this damage was from running it up and down a couple of times. Can't see that lasting. Made some bushings, friction fit, pushed them in, and I just thought I'd show you how I did that with this. So here are the bushings that already turned up. We'll just press them in. Right, those two are now done. While you weren't looking, I pushed a reamer through them so they're nice and a good fit on the bars that they need to run on. There we go. So put those to one side for the moment. This is the base plate, and on the base plate these old printer bars, these printed cartridge bars, that's the word I'm looking for. I'm using these for the vertical rods. So now these old printer bars, they get tapped, go into those holes, the three of them, then the hydraulic cylinder sits over the top, and then the rest of the stack continues. So I've worked out the gap I need here and the how much of these need to be threaded. So I need to thread these M8 to about 120 millimeters. So let me get on with that on the lathe. Had to put some gloves on. The knurling on this die holder is bloody vicious. There we go. I've threaded the three rods. I've installed them. I've just put the cylinder on so we can see a stack up of how this thing is going to go together. There's the power nut, I don't know, whatever you'd call it, and then the two rings to support the motor. Here's the motor and gear box. That fits inside there, and hopefully engages with the top of that. So what's left to do for this is to bore out both of these to fit the motor. I've got the first piece in the lathe, and I've trued it up as best I can. It's not ultra critical that it's absolutely in line, doesn't matter too much. However, the grub screws are in and just touching the flexures, so that when I machine the interior, the inside out, to the right diameter, the flexures don't flex. It will, yeah, you could end up with a situation where they flex and catch on the tool, and then it's curtains for the whole part. So I'll be taking this very, very carefully. I've only got to take about 0.5 millimeter off, so I'll get on with that carefully. Right, let's hope. Spot on. By that, I've mounted the motor onto these rings. I've tightened the little grub screws up, so now it's a bit stiff, but we can work on that. Okay folks, I'm going to pause this video here on this power drawbar build. Join me next time when we actually have a go and see what it can and can't do. So thanks for watching, please subscribe, and we'll see you on the next one. Ta-da! Hello, Fluff. Come on then. Come on. Come on. Come on. Here you go. Here you go. Come on. Come on. Up you come. Come on. Come on. Come on. Hey, you do it. There you go, Fluff. If you need of a fuss. Yeah. Yeah. Anyway. Thanks very much. Bye-bye.